I start recording. Okay, and then I share the screen. Okay, someone on the mic can see the screen and can hear me?
Yes, teacher.
Okay, so you turn to the textbook. Turn your textbook to page 57. Again, this is another quite tough topic actually. Okay, because last time they didn't learn so detailed for the old syllabus. They only learn a maximum point and the minimum point. They didn't learn the point of infractions. Okay, point of infractions. This one actually last time is for in Form 6 syllabus lah. Okay, so now you have to learn it. These are so you know it's a bit complicated lah, the whole things. Okay, so let us write the today index. Okay, turning point. Okay, this is an index for today, 23rd. Okay, we start with this. Okay, there are three types of stationary point. Okay, so stationary point, you have three types. This is the first type, maximum point, minimum point, and point of infractions. Okay, this one you can write in your exercise book as a notes. Okay, among the stationary point, there are turning point and which are not turning point. Okay, which are turning point and which are not turning point. Okay, so if we say turning point is these two. Okay, number 1 and number 2. This one we call it turning point. Okay, then the number 3 one is not the turning point. Okay, the point of infraction is not a turning point. Okay, so stationary point, okay, there are three types. Okay, maximum point and minimum point, we call it turning point. For these two, we call it turning point. And then the third type is point of infraction. Point of infraction is not a turning point. Okay, so this is a first part. Okay, introduction of the few terms for you, which is stationary point and point of infractions and turning point. Okay, so I hope you are clear. Okay, next, I want to do this activity. Okay, you can use this how to say, this website to do this activity. Okay, I can show you so that we can do this very fast. Okay, I go to this. Okay, this is the one. Okay, I go back to the textbook. Okay, to determine turning point, okay, on a function graph and their nature by observing the neighboring gradient about this turning point. Okay, actually we want to study the gradient okay, around the point. Okay, so visit this link. After that, I'll show you the link. Pay attention to the graph, okay, and the tangent to the curve at point P shown on the plan. Okay, so this is a graph. Let me check. Negative x squared. Now, can you see here? Negative x squared plus 2x, okay, plus 3. Sorry, that 2 here is the labeling for this on the x-axis. Okay, or you can check, you know, the n is 2 means the power here is 2. Okay, oh sorry, you can check the function here. Okay, negative x squared 2x plus 3. Okay, they can allow you to key in a, b, and c. Okay, and also the n. Okay, the highest power here. Okay, the tangent to the curve at the point P. Okay, point P is here. Point P is here. Okay, drag point P along the curve and observe the gradient of the curve at point P. Okay, then copy and complete the following table. Okay, so you can change the point P. Okay, you can see the tables. You can see this table. Okay, follow this table. Okay, adjust the point P. Okay, the first point P is -1. The x coordinate of the point P is -1. Okay, so I'm going to show you this, the first one. Okay, maybe you can put your textbook aside okay, together, then we do. Okay, so now point P is at -1. -1 is somewhere here. Okay, you can see this is moving. Okay, the gradient is moving. Okay, now I want to get my point P at -1. Okay, here is the -1. Okay, around lah. I can't get a very accurate one. Okay, here is -1. Okay, when x is -1, the p the gradient of the point P, at the point P is around 4 lor. You see your textbook. Okay, the first one. Okay, x coordinate at P is -1. Okay, the gradient of the curve at point P is 4. Okay, then the sign means this is +4, so it's positive. Sketch of the tangent, if this is positive, okay, is this way up. Okay, the sketching of the tangent. And this one you know already, all this. Okay, then we fill out the rest. Okay, we're going to fill out for the rest. Okay, so next is I try to move the point P to 0. The x coordinate is 0. So means I move the point P here until the x coordinate is 0. Around that lah, huh? Okay, so the answer is 2. Okay, actually it's 2. Okay, so here you see it's 2.11 actually the answer is 2. Okay, so here you fill out this is 2. Okay, how about when x is 1? Okay, so you adjust, because here is 0, here is 2, so here is 1 around here, means on the turning point. Okay, okay, x is 1. Okay, the gradient is 0. Okay, here the gradient is 0. Okay, the gradient is 0. So you fill out here 0. Okay, how about x is 2? Okay, x is 2. So here on this line. Okay, when x is 2 is a -2. Just now you see a -2. Okay, now we run a bit. Okay, it actually is -2. Okay, so this is -2. Okay, last point already. When x is 3. Okay, when x is 3 is here. Okay, just now you see -4. Okay, now run a bit. Okay, so the answer is -4. -4. Okay, so now you fill out the rest. Okay, the sign for dy dx. Okay, sign for dy dx. This one is positive. Okay, this one sign nothing. Okay, because this is 0. Okay, so this is negative. This is negative. Okay, this one maybe I can put for 0. Okay, then the sketch of tangent, if positive is this way. Okay, if negative is this way, something down. Okay, and then if the sign for the dy dx is 0 is this way, horizontal. Okay, so you see the way of the sketch of tangent is something like this, go flat and then come down and then come down. Therefore the sketch of the graph will be like this. You follow that. You see go up, flat, come down. That's why the sketch of the graph will be like this. Okay, but if you see this quadratic okay, and then negative, so you know this is set face so correct set face. Okay, so this is for the first one. Okay, then we're going to repeat for another 2 graph. Okay, which is this graph. Okay, and then this graph. Okay, I don't know where should I do. I go to words. Or maybe they have answer at the back. No. Okay, I try to go to words. Okay, we now do the step number 5. You have to give me some time because this is very difficult to explain also. Okay. Okay, now I'm doing for number 5. Okay, y equals x squared plus 2x minus 3. This is the functions. Okay, and then at the point, okay, maybe I have to build a table. Okay, the table is exactly the same as the table in the page 57. So, but this is how many points? 1, 2, 3, 4, 1, 2, 3, 4, 5 by 5 lah. Insert a table. Okay, 5 by 5 table. Okay, so the point they give here is -3. It start from -3. Okay, -2, -1, 0, and then 1. Okay, so I'm going to find the gradient. Okay, for this point. Okay, so I come back to the website. Okay, so you see this website is very powerful because they have a grade in that way that you can change the variable. Okay, so for x squared, the a will be +1. So here this change. And then for the b will be 2, same thing. For the c is -3. This one change to -3. Okay, so this is a graph. Okay, now I'm going to repeat the step. I'm going to get the gradient at the point P. For the first point, the point P is -3. Okay, so -3, I don't know where is my P already. Oh, maybe it's far away. Far away. How I want to get it. Okay, I change back. -1. Okay, get my P. I want to move my P away. Okay, maybe move to here first. Okay, secure. Okay, only change back to functions. This is next. Okay, now my P is here. Just now the P is okay at the place that we cannot see. Okay, so the first point is a -3. So -3, I move the P. Okay, x is -3. Okay, here. Okay, so let me read the gradient. Okay, the gradient is a -3.99, so -4. -4. Okay, so the gradient is -4. And x is -2. Okay, -2 is here, so it's -1.99, -2 lah. Okay, so -2. And when the x is at -1, okay, because this is at turning point. Turning point. Okay, turning point, it should be 0. Okay, it should be 0. Here should be 0. Okay, and then when x is equal to 0 here, okay, is 1.91, so it's 2 lah. Okay, here is 2. Right? when x is 1. Okay, you move here when x is 1. Okay, so 3.98, so it's around 4. So it's around 4. Okay, and then look at the sign. This is negative. This is negative. The sign of dy dx, this is 0. And then this is positive, and this is positive. Okay, then sketch of the tangent. Okay, how do I sketch? Okay, so negative is this way. Negative is this way. Negative is this way. Okay, 0 is flat. Okay, positive is this way and this way. So all together you can see go down, okay, flat, and then come up. So sketch of the graph will be like this. Go down, flat, and then come up. Smiling face. Okay, you look at this. Okay, positive. So you will see smiling face. Okay, so by determining the gradient, okay, you see, it will tell you also how the graph look like. Okay, you can roughly sketch the graph, okay, by using this method. Okay, so now we come to number 6. Number 6, there is another functions. Okay, I do off my pen. Okay. So number 6, this function is power 3 functions. So cubic functions. X to power 3 plus 4. Okay. See this today lesson is very dry. Okay, very tough. You assume you are like university student. Okay, you are pre-U student. Okay, because this one last time they put in Form 6 syllabus lah. Okay, so sorry lah but I still have to teach. Okay, wait I have to insert the table again. Okay, 5 by 5. Okay, now they change other point also. Okay, they start with -2, 1, okay, 0, okay, and then 1, okay, and then 2. Then same thing. Okay, you have to use this to get the gradient. Use the software to get the gradient. Okay. So now the n is power 3. So change to power 3. So what will happen? Power 3. So this is 1, correct? Power 3, power 2, none. So the x also none. So this is 0. Then the number is 4. Here is 4. Okay, you are getting something like this. Okay, this is the one that we're going to show that the point of inflection. Okay, so you can see the point of inflection is like a S here, like a S here. Okay, here around here you will get the point of inflection. Means here you will see the dy dx or the gradient is 0, but this is not the turning point. This is not maximum point. This is not minimum point. Therefore, this kind of point we call it a point of inflection or inflection point. Okay, same thing. Okay, this is stationary point. Okay, but this is not turning point. Mean this is not maximum or minimum point. Okay, so now we will see one by one. Okay, same thing. Okay, we start with what? We start with x is -2. Okay, so I'm going to drag the point P. Point P, I'm going to drag here. -2. Come down some more, come down some more, come down some more, come down some more. Here. I don't know where. Okay, if by calculation. Okay, if by calculations, I will going to get 2x squared. Okay, wait okay, dy dx for the x cube. Okay, I do it manually. Dy dx for the x cube is 3 x squared. Okay, so when x is -2, it should be 12. It should be 12. Okay, so means go down some more. Okay, it should be 12. Yeah, someone say something, is it? No. Yeah, come back here. Okay, sorry. Okay, so I fill out here. This is 12. Okay, next point is when x is -1. Okay, when x is -1. So I'm going to drag. When x is -1, it should be 3. 3, 3, 3, 3, 3, 3. Okay, around here. Okay, around here. Okay, around here. This should be 3. This is 3. X is 0. When x is 0, it should be 0. Okay, it should be 0. Okay, then when x is 1, we'll see what will happen. When x is 1, when x is 1, is at 3. Okay, it's 3, positive 3. Okay, and then when x is 2, when x is at 2, actually is 12 lah, but can't see lah, near here. Oh, no more already. Okay, it's at 12. Okay, this is the difference of the point of inflection with just now the maximum and the minimum point. Okay, so now we're going to see the sign of the gradient, the dy dx. So this is positive. Okay, this is 0. Okay, this is positive still. This is positive. Okay, you can see the difference from just now. Okay, I call pen. Okay, so positive, the gradient is this way, okay, 0 is this way, and then back to this way, okay. So sketching of the graph, it will be I don't know how to sketch. It will be something like this way, and then flat, and then continue this way. Okay, so that you know this is not a maximum or minimum point. Okay. Okay, maybe you will ask, do you need this method? Yes, this method, you have to use it when you want to determine the point of infractions. Okay, so I still have to teach. Okay, I cannot skip this. Okay, so now we go to number 7 in your textbook. Okay, we want to come to a conclusion already. For each of the following function that was investigated, okay, the A is the first one, this one. Okay, state the coordinate of the stationary point. Okay, the coordinate for the stationary point happen when the dy dx is equal to 0. Okay, so the x coordinate for the stationary point for the question A is at 1. Okay, this one is at 1. Okay, I don't want to find the coordinate. I'm lazy. If you want to find the coordinate, means you substitute x here for 1 to get the y coordinate. Because asking coordinate must be x and y coordinate. Okay, then for the B, okay, where is the or shall I answer all the questions first for the A? Okay, when x increasing to the stationary point, how do the value of the dy dx change? Okay, means you concentrate on this stationary point. Okay, before and after. Okay, when x increasing, okay, through the stationary point, how do the values of dy dx change? Okay, you see change sign. Okay, change sign. It change from positive to negative. Change from positive to negative. Okay, so this is a maximum point. What can you observe on the sign? Okay, it change from positive to negative. Okay, determine the type and nature of the stationary point. Okay, so this is a maximum point. Okay, this one you can come to a conclusions. Okay, at this page, the next page. Okay, so the A, just now the A is this. This is for the A. For the A just now. Okay, this one you have to write in your notes. Okay, for A just now. Okay, if the sign of divided change from positive to negative, this is what we have just now, and X increases through A. Okay, X increases through A. Okay, then the point S is a maximum point. This is maximum. Okay, now we come to the part B. Okay, part B is this one. I do it in the words. Okay, this is part B. Okay, so where is the stationary point? Okay, the dy dx is 0. So the stationary point happens when x is -1. Okay, then you see the sign of the dy dx. Okay, it's changed from negative to positive. See, negative to positive. Okay, so this is a minimum point. Okay, I come back to the notes. Okay, you see here. Okay, this is the B. This is the B. Okay, the sign of a divided change from negative to positive. Okay, S is a minimum point. Okay, even they summarize here. You see, okay, the divided change from positive to negative, maximum point. You see the shape. Don't have to memorize. Just imagine. Okay, you know positive is this way, negative is this way. So positive, negative, maximum point. Okay, you can imagine and sketch out the graph. Okay, so this is maximum point. From negative this way. Okay, and then positive going up. Okay, so this is minimum point. Okay, now we come to the third one. Okay, if the sign of dy dx does not change as x increase through a, does not change, you see here, this is the third one. Okay, dy dx 0 is here. Okay, when x is 0. Okay, so you see the surrounding. Okay, positive, positive. Okay, it can be positive, positive. It can be negative, negative. Okay, doesn't matter as long as the the sign for dy dx does not change. Okay, so we come back here. This is part C. Okay, if the sign of the other does not change, okay, then the point S is point of inflections. Okay. Okay, so for your information, just like I have mentioned already, okay, a stationary point is known as a turning point if the point is a maximum or minimum point. Okay, therefore, point of inflection is not a turning point. Okay, so this is the concept lah, Okay, you can see more. This is another example. Okay, this is another example. Okay, so you see the point A, dy dx is equal to 0 at point A. Okay, so this is a stationary point. Okay, so but what is the nature of this point? When they ask what is the nature of this point, means they are asking whether this is a maximum, minimum, or this is a point of inflection. Okay, so you got to see before and after of this stationary point. Before, the gradient is positive. After, the gradient is negative. So this is maximum point. Okay, we look at point B. Okay, dy dx at the point B is 0. So this is another stationary point. Okay, so same thing. Before, the gradient is positive. The gradient is negative. After, the gradient is positive. Therefore, okay, this is a minimum point. Okay, negative change to positive. This one is positive change to negative. Okay, how about point C? Point C, this one we call it point of inflection. Okay, this one actually you want to draw in your notebook also can. It's a summary of these 3 points. Okay, so at the point C, same thing, dy dx equal to 0. This is a stationary point. But what is the nature of this stationary point? Okay, you see before, okay, the gradient is negative. After, the gradient is still negative. Means the gradient does not change. Okay, the sign of the gradient does not change. Okay, therefore, this is point of inflection, and this is not a turning point. Okay. So you see, I repeat and repeat and repeat. So I hope that when you do the exercise, you will know better. Okay. We will go to page 60. Page 60. Okay, same thing. Okay, same concept. Okay, this one I don't want to go to deep. Okay, I don't want to go to deep. I want to just straight away show you this. Okay, other than just now the table method, the table method they call it sketching of a tangent method. Okay, there is another method for you to know that the point is a maximum or minimum or not. Okay, by using the second derivative. You learn second derivative. Now is the time to use it. Okay, so you see a turning point on the curve is a maximum point when dy dx is equal to 0. This is confirmed. Okay, because the gradient must be 0, and the second derivative is smaller than 0. Okay, remember, smaller, okay, is maximum. Okay, so sorry, got class. After I call you back. Okay, then after 10 o'clock, okay, bye. Okay, sorry, continue. Okay, so the other conclusion will be the same thing. Okay, the other conclusion will be the same thing. Here. Okay, another page already. Okay, a turning point on the curve is a minimum. Okay, so just now is smaller than 0. Now it's bigger than 0. Okay, so this one you have to remember lah. Okay, you just always remember it's the other way around. When you get the second derivative is positive. Positive mean is minimum. Negative mean maximum. Okay. Then we'll see how to solve the problem. Okay, so now you know already. Okay. So we straight away go to the example. Okay, look at this example. Okay, giving the curve. Okay, find the coordinate of turning point of the curve. Okay, when you see this is turning point or this is a stationary point, we don't care. We do dy dx first. Okay, we try to avoid using this table method, the sketching the tangent method. But when you find the point of inflection, you got no choice. You still have to use this method. Okay, so this is a turning point. So if this is turning point, you know that this question got no point of inflection. Okay, if this one they say stationary point, then you got to be careful already. Okay, stationary point may have point of inflection, may not have point of inflection. I tak tahu. Okay, I don't know. Okay, not sure. Okay, so this one they call it turning point. So you are quite sure this question got no point of inflection. So try to avoid using this table. I know you don't like the table. I also don't like the table. There's so many things need to find. Okay, but after that, another example for the stationary point that have a point of inflection, that one got no choice. You have to use the table. I will show you after this. Okay, so now I go to maybe I use pen here. Okay, so this is example 16. Okay, the function is this: y equals to x to power 3, 3x squared, 9x, 11. Okay, so part A. Find the coordinate of the turning point of the curve. Okay, so first of all, don't know what to do also, just divide dx. Okay, so differentiate 3 x to power 3. I don't want to ask question one by one. I want to be fast. No time already. So 3x squared. This one 3 times 2, 6x. This one -9. Okay, so differentiate this. Okay, for you to find the stationary point or the turning point, let dy dx equals 0. Okay, because at the turning point or the stationary point all the same, dy dx equal to 0. Their gradient is 0. Okay, that's why you need to find dy dx first. After that, let the dy dx equals 0. So you will come to this. Okay, you will come to this. Okay, then next, this one you can divide by 3 every terms. After that, factorize. Minus 3 plus 1 negative 2. Okay, so correct. Okay, therefore, x is negative 1 and x is 3. Okay, so you have the 2 points. Okay, they want the coordinate. So this is only the x coordinate. Okay, therefore, you need to find the y coordinate for each. Okay, so you continue. Okay, so when x is negative 1, okay, y is the answer is 16. Okay, when x is 3, okay, substitute, same thing. Substitute here, the y one, not substitute here. Okay, sometimes the student, they do and then blow already, don't know where to substitute. Okay, you want to find the y coordinate, you have to substitute back here to find the y. Okay, so minus 3 squared minus 9, 3 plus 11. Plus 11. Okay, so the answer is negative 16. Okay, so the 2 point is, okay, I'll write here, the 2 point is negative 1, 16, and the other point is 3, negative 16. Okay, so this is for part A. Okay, part B, determine whether each of the turning point is a maximum or minimum point. Okay, so I'm not going to use the sketching of the tangent methods. So I'm going to use a second derivative method. Okay, so I'm going to differentiate one more time. Okay, so differentiate this one more time. So 6x minus 6. Okay, 6x minus 6, correct? Okay, so I want to test. Okay, when x is equal to negative 1. Okay, the first point, x is equal to negative 1. I want to see what happened to the second derivative. Okay, substitute x as negative 1 here. Okay, so this is negative 6, so negative 12. Okay, so smaller than 0. Okay, so remember, when this is smaller than 0, is negative is maximum point. Okay, so therefore, this point is maximum point. Okay, usually 1 point is maximum, the other point is minimum, but we still have to test. Okay, so when x is 3, find the second derivative. So 6 times 3 minus 6, 12. Okay, so this is a positive. When positive, this is minimum. Okay, so 3 is 16. Okay, this is minimum. Okay, that's all. Easier. Okay, compared to the textbook method. Okay, this is easier. Okay, now we go to example 17. Okay, example 17. Okay, I'm going to open a new page. Do you want to save? Yeah, don't save. Okay. So this is example 17. Now this example, they are not asking anymore in turning point. They are asking for stationary point. Okay, find the stationary point for each of the following curve and determine nature of each stationary point. Okay, there are two questions here. Okay, so I try to show you one by one. Okay, part A. Okay, part A I think is a repeat like just now. Never mind, I can show you one more time so you have more confidence on it. Okay, first of all, okay, differentiate it. Okay, then remember, okay, let dy dx equal to 0. Okay, this one every term can divide by 6. Okay, then factorize it. Two minus 1, 1. Okay, so therefore you get the answer -2, and the other one is 1. Okay, -2 and 1. Okay, so you have these two. Okay, so find the stationary point. Okay, determine the nature. So I don't know whether this is turning point or this is point of inflection. Okay, so very simple. You just find the second derivative. Okay, but before that, you have to find the y coordinate because they want the point. Okay, they want the point. So remember to find the y coordinate. Okay, the y is 2, -2, power 3, 3, -2, power 2, 12, and then -2, and then plus 5. Okay, the answer is 25. Okay, for the other one, the same thing. Okay, 2, and then power 1 power 1 power 3, and then 3, 1 power 2, 12 times 1 plus 5. Okay, equals, okay, this one answer is -2. Okay, so you have a point -2, 25. The other point is 1, -2. Okay, now we want to test whether this is a minimum point, maximum point, or this is a point of inflections. Okay, so we find the second derivative. Okay, second derivative means this one you differentiate one more time. Okay, so 12x plus 6. Okay, so when x is -2, we want to find, see what the second derivative is what. Okay, so 12 -2 plus 6. Okay, so answer is -18, smaller than 0. Okay, when smaller than 0, very good. Okay, straight away make the conclusions. Okay, so -2, 25. Okay, negative, so this is maximum point. Okay, then the other one, when x is 1. Okay, find the second derivative. 12 times 1 plus 6. Okay, this is 18. Okay, when this is positive, then minimum point. So 1, -2. Okay, this is minimum point. Okay, done. Okay, so this one got nothing to do of a point of inflection. When you get the second derivative is 0, then that one is a point of inflection. But you cannot, by using the second derivative is 0 and then straight away make the conclusion that is point of inflection. You still have to show by using that just now that table method. Okay, the sketching of the tangent method. Okay, so this is question B. Okay, so I show you question B. Okay, still the example 17, part B. Okay, so first of all, same thing, differentiate it. Okay, then let the dy dx equal to 0. Okay, can divide by 4. After that, you can factor out x squared. Therefore, your answer x is 0. The other one, x is 3. 0 and 3. Okay? So same thing for these 2 points, you're going to find the y coordinate. Okay? When x is 0, y is 0 minus 0 plus 1. So this is 1. Okay, when x is 3, the y coordinate is 3 to the power 4. 4, 3 to the power 3 plus 1. Okay, this one, the answer is negative 26. Okay, so you have a 2 point now. One is 0, 1. Okay, the other point is 3, negative 26. Okay, so we continue with the second derivative. Okay, second derivative. Okay, so differentiate this one more time. Okay, so 12 times 2, 24. Okay, x. Okay, now, okay, when x is 0, okay, what happened to the second derivative? Okay, 0 minus 0. This is 0. This one, okay, you got to use the table, okay, to test whether this is a point of inflection or not. Okay, so how to test? Okay, you want your table? You can see your textbook lah, huh? You want a table? Okay, when x is 0, this is the x value. Okay, this is 0. Okay, then you choose a point a little bit on the right of the 0. Okay, the textbook choose 0.1 and a point a little bit left hand side from 0. Okay, so negative 0.1. Okay, then you test the dy dx. Test the dy dx means substitute x here. Substitute x here. Okay, then substitute when x is equal to 0, this one definitely is 0. When you substitute x is 0.1, okay, I just follow your textbook, this one you get negative. Okay, when substitute x as negative 0.1, this one also you get negative. Okay, so remember, if this one both are same sign, then only you can conclude this is point of inflection. If this is different sign, then this is not point of inflection. Not point of inflection, and then also not a turning point, means not a maximum or minimum point. But I don't think they will give you this kind of questions lah. Okay, so continue. Okay, the sign of dy dx. So negative, 0, negative. Okay, so here actually you can stop already. Negative, 0, negative. Here you can stop already. The rest actually not that important. Okay, so you remember the sign does not change. Okay, around the how to say, around the stationary point. Okay, you can make the conclusion already. Okay, changing from negative to 0, then there is no change in the sign vector. Okay, therefore you can make the conclusion saying that 0, 1, okay, is the point of inflection. Okay, remember there is one more point, the 3 and negative 26. So the same thing. Okay, when continue when x is 3, so the second derivative, okay, so 12, 3 squared, 24 times 3. Okay, this one you are getting 36. Okay, positive, greater than 0. Okay, positive, greater than 0. So this is minimum point. Okay, 3 negative 26 is a minimum point. Okay, I hope you are clear. Okay, we have 3 more minutes. Maybe we we quickly, go through the whole process. Okay, you have to help me. Okay. Okay, so first of all, they will give you the function. Okay, so what you have to find first. I don't know whether if I ask questions, I think I got no time to wait for your answer because I got next class to go. Okay, first thing you find dy dx. Okay, second thing you let the dy dx equal to 0. Okay, equals to 0. This one for you to find the x value. Okay, x equals to what? Okay, then after you get the x equals to what, okay, substitute to find y equals to what. Okay, then to get the point. Okay, to get the point. Okay, usually it's more than 1 point. Okay, fourth, okay, you find differentiation one more time. Okay, so find the second derivative. Okay, after that substitute. Okay, substitute the x into this. Okay, find this one. Okay, at x equals to the. Okay, so this one after you find it, okay, if your second derivative is positive, so you can make a conclusion that point is minimum. If this is negative, then you can make a conclusion this is maximum point. If this is equal to 0, then you have to go to the table method. Okay, the table method is called sketching of tangent method. Okay, I bracket lah, I say table method. Okay, the table method you got to show it around the stationary point, no change of the sign of a dy dx. Okay, then only can make a conclusion this is point of infraction. Okay, I think it is clear lah. Okay, so you follow this step. Okay, now it's 9 o'clock already. I have to stop now. Okay, so today homework will be exercise 2.10. You see 2 questions only, but the first question itself, got 8 questions. Is going to killing already. The 8 questions. Okay, because each questions you at least 1 page, 1 full page. Okay, so I will stop recording.